Hello everyone and welcome. What you're looking at right now is a fully animated, 8-direction, top-down character. Every walk cycle generated with AI and running live inside Unity. Today I'm going to show you exactly how I built this using sorceress.games, from the very first image prompt all the way to a playable demo. Let's get into it. We're going to start right here on sorceress.games. The first stop is the image generator. This is where our character is going to come to life. Inside the image generator, you'll notice there are several AI models available. One of the things I really like about this tool is that you can run a single prompt across multiple models at the same time and compare the results side by side. Grok Imagine is a great option here, and it's also the most affordable, generating a batch of 6 images for just 6 credits. I generated this character in a separate session. The prompt was a detailed description of a female warrior with short red hair, leather and metal Nordic armor, and a long red cape. Now the issue is that this image is in a flat, front-facing T-pose, which doesn't work well for top-down 8-direction movement. I need to regenerate it with a more top-down angle. So I'm going to drop this image into the reference box here and use it to guide the next generation toward the correct perspective, along with a couple of previous generations I did using it as reference, where I was already exploring different angles. That way the model has a clearer picture of the direction I'm going for and better character consistency. Before I hit generate, I always make sure to check my settings. For sprites, I go with a 1:1 aspect ratio, set the quantity, and select which models I want to run. I've also prepared my prompt. Use the provided reference character exactly, same design, colors, and style, top-down 45-degree angle, front-facing south toward the viewer, natural idle standing pose, solid bright green background, no shadows, no T-pose. Interesting. It looks like having those extra references in the box actually overrode the angle I specified in the prompt. The model prioritized the visual references over the written instruction. Let me remove those and try again with just the original character image as the only reference, so the prompt has more control over the result. This time I'm bumping the quantity up to 2 so I get more results to choose from. Same prompt, hit generate. Right away I can see one of the results is exactly what I needed. The angle is right, the character reads clearly, and the green background is clean. I open it up for a closer look to make sure everything is there before I commit to it. The pose is natural, the proportions work for a top-down view, and it's consistent with the original design. This is the one. I'll go ahead and favorite it so it stays easy to find as I move through the rest of the workflow. I drag the image I just favorited into the reference box, then scroll down to another result I liked from a different angle and add that one too. This time, I'm going for the north-facing sprite, the character walking away from the viewer. New prompt added. Let's see what we get. Same character, top-down 45-degree angle, facing north away from viewer, walking away, green background, pixel art. I click on one that looks close, but I want to see if it holds up to a few more generations as the best option. I run another round, take another look at the results, and go one more time. This time, one of the results really stands out. The angle is right, the character reads clearly, and the green background is solid and clean. That's the one I was looking for. I favorite it and move on to the next direction. I repeat the same process for each remaining direction, using the favorited images as references and adjusting the prompt each time to change the facing angle. Once I have all 5 directions I need, the other 3 will simply be mirrored in the game engine, so there's no need to generate those separately. Once I have my character images ready, I can send them directly to the next tool without downloading and re-uploading anything. I hover over the image, click Send To, and select Video Generation. And just like that, we're taken straight to the video generator with the character already loaded in the Start Frame box. We have our starting frame, but we still need a prompt that describes the movement as precisely as possible. I type in character walking forward toward the viewer, natural human walk cycle, weight shifting side to side, arms swinging gently opposite to legs, feet lifting and stepping alternately, subtle up and down body bob, hair bouncing naturally with each step, cape swaying and flowing forward with movement, chest moving naturally with body motion, in-place animation, character stays centered in frame, no camera movement, no zooming, green background. I'm using Grok Imagine Video set to 1 second duration. 1 second tends to give the best results for looping animations, and it's actually the only model that can be set to that duration. Shorter generations give the model less room to hallucinate, which means cleaner, more consistent cycles. The other models are still available if you want to experiment, but for this workflow, Grok Imagine is the one to use. I'll generate a few variations so I have options to pick from. I run a few generations and keep the ones I like most. But rather than locking in a choice right away, I'm going to wait until I have a few results from the other directions as well, because the animations can vary quite a bit between generations, and I want to pick a set where the movements feel consistent across all directions, as if it's the same walk cycle viewed from different angles. I head back to the image generator, filter by favorites, and pick the next direction, the north-facing image. I send it straight to the video generator the same way, adjust the prompt to match the new direction, and run a few more generations. After a few tries, I find one I'm happy with, delete the ones I won't use, and repeat the same process for each remaining direction, until I have all 5 animations ready to go. Now we're going to process each video and turn them into sprite sheets. I hover over one of the videos, click Send To, and select Auto Sprite. Next, click on Process Video. This tool takes the video and breaks it down into individual frames. On the right, we have the individual frames, and on the left, we have the corridor key, which handles the green background removal. I can select the key color and use the slider to fine-tune the tolerance. And there's a live preview right below, so I can see exactly what's being removed in real time. 92 seems to be the sweet spot here. I go ahead and process the sprites. I repeat the process with all 5 videos. Once they are all done, I open one of the results, and here we can see the character in the center with the green background removed. I hit play, and the animation runs through the frames. On the right, we have the individual frames, and while we could toggle them off here, it's better to leave them all on and let the next tool handle the selection. Below, we have the option to download the sprite sheet, a zip, or send it directly to the Sprite Analyzer, which is exactly what we're going to do. Here in the Sprite Analyzer, we can review and clean up the animation before exporting, removing any frames that are out of sync or interfering with a smooth looping cycle. I hit play on the animation preview to see how it flows, then move to the frame selection area. I start by selecting a single frame, and by holding Ctrl as I click, I can add frames one by one to the animation, and every change shows up live in the preview instantly. I can select all frames again with a double click, and deselect any empty or unwanted ones by holding Ctrl and clicking them. And if you ever forget how the selection works, the options are listed right there in the top right corner of the viewport for quick reference. Now it's time to create a clean loop. In this case, the character does more than one step cycle across the full animation, so I need to find the right subset of frames that creates a perfect left and right arm and leg cycle that loops seamlessly. I watch the cape, the arm movement, and the legs closely as I trim frames from both ends of the sprite sheet, turning them off one by one until I find the set that flows naturally from the last frame back into the first without any jumping or stuttering. Once I'm happy with the frame selection, I can test it before committing. I press the purple button above the preview window to open the playground. Here, I can move the sprite around using W, A, S, D, or the arrow keys, just like in a game, and it even rotates the sprite depending on the direction I'm moving. It's a great way to make sure everything feels right before exporting and taking it into the engine. Back in the Sprite Analyzer, under the preview on the right panel, we have frame alignment options. Both manual, where you can adjust frame by frame, and an auto center option that lets you align vertically, horizontally, or both axes at once. In this case, I'll use horizontal only to keep everything consistent. I rename the sprite sheet to something clean and descriptive and download it. After the download, I drag the sprite sheet back onto the screen to take a final look at the output, and it's looking good. I take my time going through each one to make sure they all came out clean before moving on. I repeat the same process for all remaining animations, working through each direction one by one until I have all 5 process sprite sheets downloaded and ready to import into Unity. One handy thing worth mentioning, from the Auto Sprite tool, you can select multiple sprite sheets at once and send them all to the Sprite Analyzer in one go. And once you're done editing each animation, you can download all the sprite sheets together with a single click instead of one at a time. Now all we need to do is drag the downloaded sprite sheets into an appropriate folder in our Unity project. In this case, I have a Sprites folder with a character folder inside. I select a sprite sheet and open the sprite editor from the inspector on the right. Once inside, I open the Slice dropdown and change the type from Automatic to Grid by Cell Count. I enter the correct values, 6 columns and 5 rows in this case, and hit Slice. Unity slices each frame correctly, and it even detects the empty space in the bottom right corner and ignores it automatically. Once that's done, it's important to hit the Apply button in the top right corner before closing the editor. We repeat the process with all the sprite sheets, applying the correct column and row values for each one. It's also worth paying attention to the sprite size. When you select an individual sprite, you can see the width and height values in the bottom right corner. In this case, 512 pixels. Head back to the inspector and make sure the pixels per unit value matches that number. Let's go back and correct that on the previous one. Make sure to hit Apply and then finish the slicing process with all the remaining sprite sheets. Now we need to create an Animator controller. I right-click on an empty area in the folder, go to Create, then Animation, and select Animation Controller. I name it Player_Animation. I double-click it to open the Animator window. This is where we manage all the animation states. I right-click inside the Animator window, select Create State, and choose the Empty option. It will connect by default to the entry node. Don't worry about that for now. I click the created state, rename it to match the animation, walk_north in this case, and repeat the process until I have one state for each of the 5 animations. Next, we need to create the animation clips. I expand a sprite sheet in the project panel to reveal all the individual sliced frames, click the first one, then hold Shift and click the last one to select them all. I drag them directly into the scene, and Unity prompts me to save an animation file. I rename it to match the direction and save it. The sprites that were dropped into the scene can then be deleted by selecting them in the hierarchy and pressing the Delete key. I repeat this process for all 5 sprite sheets until I have all the animation clips ready. Back in the Animator, I now need to assign the animation clips to their corresponding states. I select a state node, and in the inspector on the right, I click the small circle next to the motion dropdown. This opens a selection window where I can pick the matching clip. I select North for the North state and continue assigning the correct clip to each remaining state until all 5 are wired up. I had already created an empty player object in the hierarchy and added a sprite renderer and a rigid body 2D component to it. I open the character sprites folder, pick one frame to use as the default sprite, and drag it into the sprite field on the sprite renderer. Next, I add the Animator component to the player object and drag the player_animation controller into the controller field. This connects all the animation states we set up earlier to the player. Next, I create a scripts folder to keep things organized, and inside it, I create 2 new C# scripts. One named Player Controller, which will handle the character movement and animation, and one named Camera Follow, which will handle keeping the camera locked on the player. To assign the Player Controller script, I simply drag it onto the player object in the inspector. I had an AI write the code for me, and it exposes all the animation speed variables directly in the inspector so I can fine-tune each direction while testing without touching the code. For the Camera Follow script, I do the same, drag it onto the main camera. This one needs a target to follow, so I drag the player object into the target field, and the camera is now locked onto the player. I hit play, and it works. The camera follows the player smoothly, and all the animations play correctly across every direction. That's the full workflow, from AI-generated image all the way to a playable character inside Unity. And that's it for this one. I hope this gave you a clear picture of the full workflow, from generating your character with AI all the way to a playable animated sprite in Unity. The link to sorceress.games will be down in the description so you can check out all the tools we used today. If you found this helpful, leave a like and subscribe for more. See you in the next one.